If you are researching the treatments of depression with photobiomodulation, you will no doubt come across the published work of Dr. Paolo Cassano. In his presentation here, he evaluates the relationship between different parameters and the antidepressant and anxiolytic effects of transcranial photobiomodulation. This should be very interesting because he is demonstrating more precision in the photobiomodulation parameters to improve treatment outcomes. Dr. Cassano is an assistant professor in psychiatry at Harvard Medical School and a director of photobiomodulation at the Massachusetts General Hospital Division of Neuropsychiatry and at its depression clinical and research program. He has served as a principal investigator on multiple studies on transcranial photobiomodulation for several important neuropsychiatric disorders, such as major depressive disorder, generalized anxiety disorder, mild cognitive impairment, and Down syndrome.
Hi, the title of my presentation today is Photobiomodulation for Depression, Anxiety, and PTSD, the MGH brain-PBM clinic dose map. My name is Paolo Cassano. These are my disclosures, and none of these are pertinent to the data that I'm going to present today. So we are all excited about photobiomodulation. Here are many centers in the United States that are actually using this technology for therapeutic purposes, and not only for transcranial purposes. So when we look at the field is clearly growing. Here you see two colors. One are the referred to the number of publications in blue before 2004, and for the same wavelengths, the number of publication after 2004, so 2005 to our days. And you clearly see that the number of publications are increasing fast. However, we've looked so far at the glass half full, and I think we have to stop to do that. We have to look at the glass half empty as well. We certainly have experienced many failures, at least in our group here in MGH in Boston. And we think that those failures might be telling us a story. So let's look in general at the field in terms of neuroscience, psychiatry, neurology. How are they looking at photobiomodulation? And if we just look at the treatment option for depression and we look at the field, we clearly see a large amount of publications around antidepressant medication for depression. Pretty large for transcranial magnetic stimulation for depression, which is the main technology for device-based treatment for depression. Still, a very large amount of science is produced for cognitive behavioral therapy for depression. But when you look at photobiomodulation, we are still far behind. And this is photobiomodulation altogether. So if you think about transcranial photobiomodulation or photobiomodulation for the brain, the amount of science, the amount of attention that scientists are giving to this field is still far less. So what about those failures? We certainly have experienced some. Despite that, we have experienced, and we still are experiencing, a lot of enthusiasm. This is one of our teams here in MGH. Their excitement is palpable for their new device that they're using in their trial. So when I think about failures, I think about the quote from Teddy Roosevelt. The credit belongs to the man who is actually in the arena, whose face is marred by dust and sweat and blood, who strives valiantly, who errs, who comes short again and again, because there's no effort without error and shortcomings. So with that in mind, let's start to see what happened in our quest for treatment for depression. So these are the studies that we conducted at the Harvard Medical School. This was the first study by Schiffer at the McLean MGH. And yes, we looked at this beneficial effects of the light. This was one treatment. This was the depression scores after 2 weeks benefits, but yet those benefits were not lasting that much. We continued with our group here at MGH. We did a pilot with the Neurothera device. We found that with 6 treatments, we were finding significant benefit, and yet within this graph, hidden, there were already those 2 remitters that at week 6 or 7 were starting to creep up with their scores of depression. We did another study, this time randomized, double-blind, placebo-controlled with the Omnilux New device, and we did see a benefit from the light, even some significance. However, you could see that the treated group hardly separated from the sham group, despite twice-a-week treatments for 8 weeks. Finally, we did a two-site study with NYU, and there was no separation whatsoever. Here you see the sham group in orange and the NIR group. This was the first phase of the study, and this was the second phase of the study. At the end, treatment or no treatment was exactly the same. So quite some failures and quite some disappointments. So the question is, what did we miss? And I guess the first thing that comes to mind is when we look at the doses, we were operating under the assumption that all this treatment were the same, that we were just delivering photobiomodulation. We might have had some preferences for one device or the other. But when you look at the dose map, and this is a map that has plotted the surface, the window of the treatment and the radiance of the treatment, and also looking at the total energy per session in kilojoules, you could see that those treatments were fairly different. And the very first promising trial from Schiffer had fairly higher radiance than our next 2 trials. So we didn't quite see that coming. And we didn't quite look so much in depth to the field in general, in terms of their dosimetry. It turns out that even in the field, there were many different studies with different dosimetries. And it turns also out that the studies that use higher surface and higher radiance, thank you for the use of pulse light, were the ones that were getting the greatest effect in terms of antidepressant effect, which you didn't expect. And that was also true when we combine both the field altogether and the studies we were conducting here locally in Boston. What else? Well, we had another assumption here. This was that if we could only engage the brain function, if we could only modulate the brain function, then we would have an effect, and an antidepressant effect. Well, it turned out that even that wasn't quite true. There were studies that indeed showed an effect on cerebral blood flow and a therapeutic effect. Here indicated in red, those are the studies that were most beneficial for depression. But there were other studies with devices that had proven to affect the brain function, which yet didn't lead to much of an effect when we were looking at the clinical antidepressant effect. So also that wasn't quite true. You probably needed to engage certain functions, and you probably needed to engage maybe certain brain areas. And so that was an assumption that was misleading for us. Altogether, we were missing a framework to look at dose and dose mechanisms. We were also under the assumption that near-infrared light had different effects. It could boost brain blood flow. It could boost brain oscillation had a lot of systemic effects, maybe anti-inflammatory, antioxidant, and all of that was going to contribute. Well, let me tell you our story here and what we just found in our study at MGH. These are preliminary results of a single blind study. That's why we could analyze this data. We're looking at cerebral blood flow, and we're looking at different doses, like low irradiance, high irradiance, sham, and our depressed subjects go each week through a different test in the MRI with different doses. We saw clearly that the high dose was leading here during the treatment in orange, a spike of cerebral blood flow, and in yellow, after the treatment, was also quite visible. However, when you looked at the low irradiance dose, there was really no difference, and no difference also compared to the sham. So here we are. We were not expecting this. So that means that high irradiance has an effect on cerebral blood flow, but low irradiance doesn't. That's what the data seems to tell us. We look back at a study that we had conducted with Northeastern University, and we had exactly looked at these prototypes of treatment when we were modeling the penetration of the light with high irradiance and low irradiance. And with high irradiance, we were getting towards the dorsolateral prefrontal cortex, our target for the treatment of depression, an average energy deposition influence, which was above that threshold of 0.3 joule per square centimeters, validated in vitro models, which is the threshold for modulating the cellular function in a positive way. However, when you looked at low irradiance, we're just about threshold, and that's a median. That means like half of that area doesn't receive enough light. So that was interesting. That made sense. We were basically didn't produce enough photon deposition to have an effect. However, in a different study, we looked at the same exact irradiance, similar total energy per session. And with that, we looked at brain oscillations, electrical oscillation. And we found that after treatment, the oscillations over gamma activity were clearly increased as compared to before the treatment. So that was strange. So all of a sudden, there was no effect on blood flow at lower irradiance, but there was an effect on EEG recordings. And for a light dose, that wasn't quite supposed to get to the brain anyway, or at least not enough. So we had to come up with a different framework. So we thought, okay, well, high irradiance means photon deposition to the cortex and means a direct effect that is related to the deposition of the photon to the neurons. But lower irradiance might still have an effect on EEG. And even though there's little or no photon deposition to the cortex, and we have to assume that something else is happening. Maybe an electromagnetic field, maybe a low current over the skin. Something else is happening here, which we don't quite know. Now, I know that the field talks quite a lot about systemic effects. However, the reason why we didn't quite think that those systemic effects were at play here is because the actual surface was fairly small. And so how can you explain a lot of effect on the blood flow in terms of blood cells, free circulating mitochondria, the blood flow in the skin this time, and systemic effects deriving from that when you have such a small surface? And how can you expect effects on the brain that's so happening so fast within minutes from the stimulation? So that's why we thought that maybe systemic effects were not at play here when we were looking at the gamma announcement. However, as a team, we absolutely believe that there are systemic effects from shedding the light. In fact, we had looked with Philip Gable in Australia at shedding the light extensively over the back and the thighs. And we had seen here that when you were treated with photobiomodulation, this time on the body, with physical therapy compared to physical therapy alone, you had a much better outcome in terms of depression scores when photobiomodulation was added. And this was not just about controlling pain or improving functioning, because the two groups were just identical from that standpoint. So we do believe on systemic effects, and we are well aware that mood and mitochondria have a connection. We know that when someone is depressed, there are effects where the brain, I'm sorry, I'll take it back. The mitochondrial membrane is affected, is more permeable. There's damage at the mitochondrial DNA. There's less ATP production. The electron transport chain is affected, which leads to more oxidation, more inflammation, cellular death, and of course, a disruption in function. So that is all happening. We just believe that that might be happening in terms of effect of light on systemic processes might happening more when the surface of irradiation is wider, and therefore there is a greater vasculature that is irradiated. So what else we might have missed? We didn't quite think about depression and the different types of depression. Now that we have this framework, we are now considering, well, if we have a high radiance treatment, maybe those type of vascular depression, which are late onset depression, late life depression, are more likely possibly to benefit from high radiance. And those cognitively impaired, depressed subjects who have maybe poor concentration or maybe some word finding difficulties, or maybe even just cognitive side effects or medication may benefit as well from lower radiance. And the subjects who had medical comorbidity with chronic medical illnesses, inflammatory disorders, might actually need a higher surface to have those extensive anti-inflammatory, antioxidant effects. But back then, we didn't have this framework. So let's look more closely to our theory. So definitely, there's a prototype of treatment with a lower radiance and lower surface, as long as it's not too low, where we might have no effect whatsoever, where we affect gamma and fast oscillation, and we have that enhancement. That's a very well-known process that is altered also in depression. So that's a reasonable target. However, we believe that that effect might still be lasting or happening when there's high radiance. So truly, when you use high radiance, you might have two combined effects. And that effect might be lasting and might be present also when you use higher or larger surface. So even this other quadrant most likely includes two mechanisms. But now I guess you are already anticipating that when you have both higher radiance and larger surface, all of a sudden you have, according to our theory, you have three mechanisms at play that all have meaning when it comes to depression. And then maybe all types of depression, that's our speculation, might be benefiting from this dosimetry. So what are the data telling you? Well, it seems like it fits quite well the data. In fact, those studies that had higher surface and higher radiance, thank you to the pulsing, and also higher energy deposition per session, were the studies that led to the greatest benefits. So there might be something to this theory. What else we missed? it's not all over, I can tell you. Until now, I spoke as if we all had the same head, but truly we don't. And we don't have all the same brain either. And, surely when you look at transmission of the light through the depth of the brain, you see this exponential decay. The more you go in depth, the less light gets there. But look what happens when you put together all these dots that are average here. Those are 20 cadaver heads, and you are actually shooting the light to different spots of the skull. And you can clearly see that the penetration varies a lot. So that's an issue that we didn't quite take into consideration. But that's not the only issue when you get to personalizing the treatment. So if you have elderly patients who might have some atrophy, or if you have people who have more pigmentation in their skin, all of a sudden you have to push harder and you have probably a higher threshold of irradiance to get into this higher quadrants. If you have younger patients with a smaller head, children, adolescents, in your less thick tissues, then you most likely will have a lower threshold to get into these higher quadrants. Same thing if you have more severe systemic diseases with more disruption, inflammation, especially when they are poorly controlled, probably you need a greater surface of irradiation to get to that kind of right quadrants that you want to see for the systemic effect. However, if you use your diet and maybe you have methylene blue as a pharmacotherapy in conjunction to the treatment with photobiomodulation, transcranial photobiomodulation, you might sensitize your mitochondria and you might need less surface to have some of those benefits. And if you had a mitochondrial disease, so that's also speculative, your mitochondria might be so impaired that you definitely need more in terms of threshold of high irradiance and overall surface. So we need to think about this as an individual threshold. And that's something that we didn't think at all about. So I'll reassure you that I'm at the end of my talk. I'll just say about anxiety and PTSD that there's not much data. The field is just starting to evaluate this, and there are studies that were done in generalized anxiety, studies that looked at comorbid PTSD, but high irradiance seem again promising, even for anxiety. Ongoing and future studies, there's a lot to wait for. I'm very thankful to Dr. Francisco Gonzalez Lima that allowed me to present this very telling and encouraging data that also are pertinent to the high irradiance portion of the treatments or the quadrants of our models. So here you see in red patients with depression that received transcranial infrared light. In blue, patients that received just cognitive behavioral therapy. The patient in red received transcranial light in addition to cognitive behavioral therapy. And you see this dramatic effect. So the combination beat it, cognitive behavioral therapy alone. Very promising. Many studies to come. So I expect that we'll have an opportunity to either confirm or change our theory. And for that, I will need your help, and we want to do that collaboratively with all of you. So please reach out. You saw what is our model, what we use to frame the treatment within our clinical practice here at MGH in the MGH brain-PBM clinic. We are hoping to extend this approach to the future studies so that we have a more personalized treatments. And I will conclude with the continuation of the quote from Theodore Roosevelt. So the credit belongs to the ones who know great enthusiasm, the great devotions, who spend themselves in a worthy cause, who at the best know in the end the triumph of high achievement, and who at the worst, if they fail, at least fail while daring greatly. And I think we are on track, despite the fact that we might have some failures. I'm very thankful to my team for their help, and I'm thankful to you for listening today. Thank you.